Kirchhoff's voltage law, or KVL, is one of the most fundamental principles in circuit analysis. It describes how energy is conserved around any closed electrical loop. Imagine water flowing around a closed pipe. The pump adds energy, while friction and height differences take it away. By the time the water returns to the pump, all of the energy gained has been used. The total gain and total loss are equal. Electrical circuits behave the same way. Voltage acts like pressure. It pushes charge around the circuit. Current is the flow of that charge. Kirchhoff's voltage law states that the algebraic sum of all voltages around a closed loop equals zero. The energy gained from the source is exactly balanced by the energy lost across the components. In this series DC circuit, each resistor value is equal to the voltage drop across it. Thus, summing the 2-volt drop across R1 and the 8-volt drop across R2, we get a 10-volt total drop. This sum, being equal to the supply voltage E, confirms Kirchhoff's voltage law. Observe the voltage around the circuit, represented by the red dot, starting at 10 volts, then dropping to 8 volts after the 2-volt drop at R1, and then to 0 volts after the 8-volt drop across R2, finally returning to 10 volts at the battery. This shows Kirchhoff's voltage law in action. The total voltage rise equals the total voltage drops, so everything adds up perfectly around the loop. A few common mistakes can lead to errors when applying KVL. Forgetting to include the sign convention is the most common one. Always stay consistent with your loop direction. Another is missing internal resistance of sources, which slightly lowers the terminal voltage. And finally, measurement errors in practical setups, even small resistors in wires, can cause the total voltage to not sum exactly to zero. Recognizing and accounting for these steps keeps your analysis accurate. KVL isn't just theory, it applies to real systems like battery packs, chargers, and car wiring. Energy is always conserved around each loop, no matter how complex. To sum up, Kirchhoff's voltage law shows that all voltage rises and drops around a loop must add to zero. From water analogies to MATLAB simulations, and even with real-world imperfections, the law always holds true.